Hi dear students, let's get started with a new concept of the chapter, acids, bases and salts. So far under this chapter we have covered like what are acids, what are their physical properties, what are bases, what are their physical properties, how do we test the presence of acids and bases using the indicators, and then we also discussed how does the metals react with the dilute acids and bases. Today we are going to take up the new concept wherein we are going to see how the metal carbonates and metal hydrogen carbonates react with the acids. So acids plus metal carbonates and acids plus metal hydrogen carbonates, or we can call it as bicarbonates, how do they react with the acids? That is what we are going to focus in today's video. So let us take an example of Na2CO3. See here, I call it as a metal carbonate because I know Na2 is a metal and carbonate I know it is a polyatomic ion made up of 1 carbon and 3 oxygen atoms, so it will be written as CO3. Students, one thing we need to note, wherever there is CO2, we can split the molecule as this CO3 which is there, it can be split as O and CO2. To obtain CO3, I can split the molecule as CO2 and O, and then here I have Na. Now if I break these molecules into the respective ions, I will get Na plus and CO3 minus. So whenever I make it react with an acid, think this acid also breaks down as H plus and Cl minus. Then what will I get? It is a mixture of this H combining with O, leading to the formation of H2O plus this carbon dioxide which is there, it will be liberated out, and then once this compound and this compound is over, remaining NaCl will be a salt that will be formed. So basically whenever a metal carbonate reacts with an acid, it leads to the formation of a salt, water and the gas carbon dioxide. And we already know that this carbon dioxide has got a special property where it extinguishes the fire. It extinguishes the fire. This is the property of carbon dioxide which is formed during this reaction. The same reaction will take place if I take a metal hydrogen carbonate or a metal bicarbonate. For example, if I take NaHCO3, here again this is a metal, this is hydrogen and this is carbonate. Again I can break this molecule as O and CO2, wherein if I make this compound react with the acid, simply it will lead to the formation of a salt which is after the dissociation into H plus and Cl minus and Na plus and HCO3 minus. So what will happen? This cation will react with this anion, leading to the formation of a salt called NaCl. Then CO3 which is now broken into CO2 and O, this CO2 will be given out as a gas which can extinguish the fire, and then this H which is there will combine with this H and O, leading to the formation of H2O. So to make the reaction simpler, we have to take the compounds and break them, dissociate them into their different ions and see what reaction can take place. Basically, it is a type of double displacement reaction that is taking place here, wherein we are getting to see that there is ionic exchange happening between two different compounds. So children, whenever a metal carbonate or a metal bicarbonate react with the acid like HCl or H2SO4 or NH3, basically a salt will be formed along with water and carbon dioxide. One of the property of the carbon dioxide is it extinguishes the fire. That means It will not allow the flame to burn for a longer time. The moment the flame comes in contact with the carbon dioxide, it will stop burning. That is the property of carbon dioxide. Now, keep the same reaction in mind, students, that whenever metal carbonate reacts with an acid, it leads to the formation of a salt, water and carbon dioxide. Now this carbon dioxide, think that I make it pass through the lime water, that is nothing but CaOH twice. If this lime water is passed through the carbon dioxide, it leads to the formation of, here this OH, can I break it as O plus H2O? Because I already had 2 oxygen and 2 hydrogen. That means the 2 is outside the bracket, which means I have 2 oxygen and 2 hydrogen. So I can break it as H2O and O. So this H2O will be given out plus this carbon dioxide which is there. It will react with this O and this calcium, leading to the formation of CaCO3. We know that calcium carbonate which is there, it is an insoluble substance. It is an insoluble substance. We always say that whenever CO2 is made to react with the lime water, the lime water which will be transparent in its nature, it becomes milky due to the formation of calcium carbonate. Now further, if I make the carbon dioxide pass through the solution after the formation of CO3 or CaCO3 also, what will happen? This CaCO3, it will react with the water which is already available in the solution along with the CO2 which we are passing, and it will lead to the formation of CaHCO3 twice. Now this calcium hydrogen carbonate which is there, it is a soluble substance. That's the reason why when you start passing CO2 into the lime water in the initial stages, the lime water turns milky due to the formation of calcium carbonate. If we further keep providing the carbon dioxide to this compound which is already there into the solution, carbon dioxide along with calcium carbonate react with the water which is already there in the system and lead to the formation of calcium hydrogen carbonate which is soluble in water. And that's the reason why this soluble substance will become transparent, and you see that further passage of CO2 will make the milky solution turns transparent. So that is how the metal carbonates and metal bicarbonates react with the acid. Let's take one more example to understand this better. This time we had taken the metal carbonate to be Na2CO3. Now let us try understanding what will happen if I take another metal carbonate and see if the same reaction is taking place. For example, if I take CaCO3, Ca is a metal, CO3 is a carbonate. Again, whenever there is carbonate there, it can be split into oxygen and CO2. If I make this compound react with HCl, I can dissociate this as H plus and Cl minus, this as Ca plus and CO3 minus, wherein CO3 will be dissociating into O and CO2. Now the cation of this compound will react with the anion of this compound. So what will happen? I will get to see that CaCl2 will be formed, which is a salt. Right? Simply the cation of this compound is reacting with the anion of this compound, leading to the formation of a salt called calcium chloride. Further, what will be formed? I know that this H which is there, it is H2 now. This will react with the oxygen, leading to the formation of water. Plus CO2 which is there over here will be liberated out from the system, and it has the capacity to extinguish the fire. Or if you make the CO2 pass through the lime water, it turns the lime water milky. So any metal carbonate, if you take and make it react with an acid, a salt will be formed along with the formation of water and carbon dioxide. So these are the different reactions which are really important, students. So make sure that you keep this process of dissociation of compounds into your mind, and then practice it. Now, so far we know how does these acids and bases react with the metals, and we also got to know that how do these metal carbonates and metal bicarbonates react with the acid. Now let us see how does these acids and bases react with each other. Alright, so we are going to see what will happen if I make acids react with the bases. We are studying this concept from our 7th grade students, wherein we know that whenever an acid is made to react with a base, it leads to the formation of salt and water, wherein this reaction is called as neutralization reaction. This is called as neutralization reaction because in this reaction the acid which is there, it cancels the effect of a base, and the base which is there, it cancels the effect of the acid, and as a result a neutral substance called salt will be formed, which is neutral in its nature depending on the strength of the acids and the bases, and that's the reason why it is called as neutralization reaction. Basically acids cancel bases and bases cancel acids effects, so the medium becomes neutral. That is the reason why it is called as a neutralization reaction. Now let us try exploring it taking the examples. Let us take the example of an acid to be H2SO4 plus the base to be, let us take a different base. For example, now I have taken the base to be CaOH twice, which is a calcium hydroxide. Now, whenever the neutralization reaction happens, it is a type of double displacement that will be happening. So, what will happen? This molecule will break down as H plus and SO4 minus. Ca breaks down as Ca plus and HOH minus. And as a result, this OH which is there, it will be reacting with the cation. Since it is an anion, it will react with the cation, leading to the formation of water molecules, that is 2H2O. Plus, the anion of this will react with the cation of this, leading to the formation of CaSO4, which is nothing but calcium sulfate. Yeah, after balancing the equation, this is what we will get. So, whenever an acid reacts with a base, it leads to the formation of a salt and water. So, this is what is called as neutralization reaction. Now, let us see the other example. Simple example this is going to be. If I talk about the acid HCl plus NaOH, very simple, H plus and Cl minus will be formed at dissociation. Na plus and OH minus will be formed at dissociation. Anion of this reacts with the cation, leading to the formation of water, plus anion of this will react with the cation of this, leading to the formation of salt, which is nothing but NaCl. Correct? So whenever we see that acid reacts with a base, it leads to the formation of salt and water. This is a general reaction which is called as neutralization reaction. Now, if the metals are reacting like this, the acids and bases are reacting with each other like this, through various experiments, it is observed that whenever a metallic oxide is made to react with the acid, it leads to the formation of salt plus water. Children, don't you feel that it is the same? See, I have taken an acid. In place of a base, I have taken a metallic oxide, but the result is same. I'm getting to see that the salt and water is being formed. That means these metallic oxides which are there, they act as the bases. Correct? So the bases like metallic oxides, whenever they react with the acid, they lead to the formation of salt plus water. Let us take one simple example and try understanding this. For example, if I take MgO, Mg is a metal oxide with the oxygen, so magnesium oxide. If I make it react with H2SO4, if I make this reaction to take place, if I allow this reaction to take place, I'll get to see this. Again, magnesium will break into Mg plus and O minus, H2 plus and SO4 minus, leading to the formation of this anion. This cation will react with the anion and this anion will react with the cation, leading to the formation of MgSO4 twice plus H2O, for which I have to take 2 over here and the equation will be balanced. Same thing, when a metallic oxide is made to react with an acid, a salt plus water will be formed. And then you have to make sure that you are balancing the equation. Children, are making it very simpler by dissociating the compound into its cation and anion, so that you get to understand which ion will react with which ion. So this is what basically happens. Always a cation will react with the anion, leading to the formation of a new compound. An anion reacts with the cation, leading to the formation of a new compound. So metallic oxides, when they react with acid, just because they lead to the formation of salt and water, giving the same products of neutralization, we consider that metallic oxides are basic in their nature. Now, in contrast to this, what will happen if I take a non-metallic oxide and make it react with a base? It is also observed that it will lead to the formation of salt plus water. That means it is again a type of a neutralization reaction because the products are similar to the neutralization reaction. That means, see, I have a non-metallic oxide in place of acid. I have bases. I have salt being formed along with water. That means it is again equal to the neutralization reaction. That means these metallic oxides which are there, these are acidic in their nature. The same way, students, whenever a non-metallic oxide reacts with a base, it leads to the formation of salt and water. So that means this is also a type of neutralization reaction taking place, and so we consider the non-metallic oxides to be acidic in their nature. So in this part, we actually covered 4 of the reactions, wherein we studied that whenever we make the metallic carbonates or metal carbonates and metal hydrogen carbonates to react with the acid, they lead to the formation of salt, water and carbon dioxide. And then the acids and bases react with each other, leading to the formation of salt and water, which means it is a neutralization reaction. The same way, if I make the metallic oxides react with acid, they lead to the formation of salt and water, and so we consider metallic oxides to be basic in their nature. And if I make the non-metallic oxides react with the base, it again gives the same product as neutralization, and so I consider the non-metallic oxides to be acidic in their nature. So, I hope you understood how these metals and acids and bases react with each other. See you in the next video.